All right, so we're going to go over number 12 from your Wave Study Guide packet. This talks about comparing amplitude and frequency mostly, and talking about sound waves, how these components of a wave affect the sound that you hear. So I thought it'd be helpful to just break this into the y direction. In most cases, that will relate only to the amplitude. And then the x direction. The x direction involves time and distance. So the y direction in most cases is just going to determine the intensity of a wave. So if you have a speaker and it's kind of vibrating a lot or in a very intense motion, there's kind of a larger back and forth motion, that would be a greater or higher amplitude of the sound wave. You can think of like your hand splashing or making a wave in a bathtub. If you were to lightly tap your hand on the water, you would have a pretty low intensity wave, a low amplitude. If you were to push your hand harder on the surface of the water in the bathtub, you would have a bigger wave. That's kind of similar to sound waves and the amplitude of the wave in general. When we talk about light waves, it will also be the intensity of light, which relates to the brightness. So amplitude, we've gone over this several times, but it's half of the total height of the wave. So from this rest point that I drew in black to either a crest or a trough. You could do either one. Two of these amplitudes would make up the height. Amplitude is what tells us about the loudness of a sound. So if you have a very loud song, like a heavy metal song, is usually loud, that would have a very high amplitude. That's kind of it for amplitude. Amplitude has no effect on this right half of the page. Amplitude does not affect frequency. Amplitude does not affect pitch. Amplitude does not affect frequency, wavelength, or period. Okay, so let's move on to frequency, the x in the x direction or x-axis. Frequency, I've drawn a low amplitude or a small amplitude wave with a high frequency. So this means that there would be a lot of waves passing you per second. Frequency always has to have a number of waves per amount of time. Example, 3 waves every 2 seconds. We usually abbreviate that as hertz. And again, the frequency is going to determine the pitch. Frequency usually doesn't change because it is dependent on the source of the vibration. Okay, so let's move on to wavelength. Wavelength is a distance. Notice that distance does not include time. So the distance is going to be from crest to crest. In other words, length of a wave. Okay, if you have a long wavelength in a constant medium, which means the speed of sound is not changing, you would have a very low frequency. Okay, so a sound that had a long wavelength would have a low pitch. Let me space this out a little bit. Okay. If you have a change in speed, which comes from a change in density of the medium, if you have a change in speed, then you might have a change in the wavelength. However, in general, when you have a sound wave moving, let's say from air to water, the frequency would stay constant because that's based on what is coming, or the vibrations coming from the source. Maybe it's your voice. The vibrations from your vocal cord aren't changing based on the medium. It's just the speed of the wave. So if the speed of the wave goes up, wavelength would have to increase. Speed of the wave goes down, wavelength would have to decrease. Let's move on to period. Period is just an amount of time. So usually measured in seconds. We use a capital T as a variable. That should help you remember that it's a measure of time. Okay, so let me move this down. Okay, if you do something very frequently, you have a high frequency, let's say you Snapchat 50 times per day, that's a little scary, you might need an intervention. High frequency would mean there's a very short amount of time passing between each Snapchat. Same thing for a wave. If you have a high frequency wave, that means a lot of waves are passing per second, per minute, or per day. That would mean you have a very short period. There's a short amount of time between each wave passing. Technical definition would be time for one wave to pass a certain point. So if you had a stopwatch and you started the stopwatch when the wave crossed the start line and stopped the watch when the end of the wave passed you, the time that you see on the stopwatch would give you the period. Okay. It's kind of relating frequency, wavelength, and period. If you have, connecting this back to a sound wave, if you have a high frequency or a short period, you would have a high pitch. If you have a low pitch, that would mean you have a low frequency and a very long period of time between waves. Please comment below with any questions and give this video a thumbs up.